Hello, everybody. Here is your solutions test review, the one you were working on today, and I thought we'd go through some of the material we did today. So let's just start. So let's start with course number one. Um, Universal solvent, the one that dissolves more solute than anything else, guys, that's water. H2O. Okay. When you dissolve sugar in water, you guys are good at this one. The sugar is called the solute. Water is called the solvent, right? So this one here, number three, we talked about it briefly. I'm going to talk about it a second here. A type of solution that water is the solvent, it is not what we call saturated, everyone. It's called aqueous. And you'll see that in an equation, you'll see an A and a Q for aqueous. So water as a solvent is called aqueous. A solution that cannot dissolve any more solute without raising the temperature is called what? Well, that would be saturated. We could not dissolve any more solute in there unless we raise the temperature. And then we got about 4.5, close to 5 cups of sugar in that solution. So that would be saturated. 3 factors that increase the solubility of solid solutes. Solid, not talking gases, just solids. That's temperature. Agitation, many of you said stirring or shaking. And then particle size, the smaller they are, the easier it is for it to dissolve. Okay, number 6. And a compound that can conduct electricity when dissolved is called what? And I asked you to think of like Gatorade or Powerade, okay? So when those solutes are dissolved, they have positive and negative ions in solution, and those are called electrolytes. All right? This one, many of you said solution for number 7. I saw that all day. Well, yeah, you're right. You will have a saltwater solution. That's right. But what's going to be produced when you dissociate salt, NaCl, in water, meaning dissolve it? It's going to break it apart. And the compound will break down into its respective ions. Sodium is a cation, chlorine is an anion. So it's going to break down into its respective ions here. Okay, so your test question is going to have one like that, but it's not going to be the same thing. Number 8. A property of a liquid to stick to itself and create surface tension, and most of you got this today, is cohesion. Number 9. Positive end and a negative end for a molecule. We call that molecule a polar molecule. Remember, a bar magnet has a positive end and a negative end, and we call those poles, like the North and South Pole we have here on Earth. Number 10, a solution that contains less solute that are needed to form a saturated solution is called unsaturated. That is less than saturated. So far, all this is just terminology, no math yet. Math is easy. All right, looking at your solubility rules. If they're soluble, insoluble. So the first one, AgNO3. AgNO3, there are no exceptions, it's soluble. NH4Cl, we look at this chlorine here, and we see that it's soluble, and there are no exceptions. There you go, looking at exceptions. This one right here, some of you, I gave you the wrong answer today. I don't know what I was thinking, don't know why, but anyway, my apologies. You have aluminum phosphate, and so you have a phosphate which is insoluble, and then you have aluminum paired with that. Aluminum is not an alkali metal, so it's not an exception. It is going to be insoluble, all right? And then the last, calcium sulfide. Sulfide is insoluble, but there is an exception. It's that calcium right there. That means it's going to be soluble. Okay. Which solute is least soluble at 20 degrees Celsius? Go to 20 degrees Celsius, go up and find the first curved line. There you are, KClO3. All right. How many grams of sodium nitrate can dissolve in 100 grams of water at 60 degrees Celsius? I noticed that a lot of times these numbers kind of get to you and confuse you. But if you look at this part right here, 100 grams of water, that's just giving you the units to this right here. So you can just kind of go like this, get that out of there, and we're looking at this mass of sodium nitrate at 60 degrees Celsius. So we start at 60 degrees and go all the way up to sodium nitrate. And if we go over, I guess it's around 125 grams or so. Number 17, at what temperature is 50 grams of ammonium chloride saturated? Well, start with 50 grams, and you're going to go over to the saturate line, okay? And so NH4Cl is right there, so we start at 50, go here, and go down. That would be 50 degrees C, okay? Easy. All right, here's the math. If you dissolve 0.53 moles of table sugar to make 0.180 liters of sugar solution, what is the molarity of the solution? Well, when you're doing that, 0.53 is the number of moles divided by the number of liters, and that would be 0.180 and liters, and I got 2.94 molar. That is the concentration of that solution. All right, you're going to have a problem like that tomorrow. How much, number 19, of a 3 molar hydrochloric acid solution can be made by diluting 2.25 liters of 10 molar HCl? Well, if you look at the question, read it for a second. How much 3 molar solution can be made by diluting this 2.25 liters of 10 molar HCl? Well, here's the equation. This is going to be your V1. This is going to be your M1. This is going to be your M2. And you don't know, you're trying to find out what V2 is. You're trying to find the volume. So if you rearrange this equation here, V2 is going to equal M1 times V1 over M2. Okay? And therefore M1 is going to be 2.25. Or I'm sorry, that's V1. V1 is 2.25. M is going to be 10. M2 is going to be 3.00. When you solve the problem, multiply and divide, 7.5 liters can be made. All right? Okay, last two. Which curve represents the relationship between solubility and temperature of most solids in water? This is solids, guys, not gases. So if you remember from the rock candy lab, when we increase the temperature, solubility is supposed to increase, and it does. The only one that does that kind of curve, is this one right here. All right? That's easy. And then, well, look at that line, by the way. Temperature increases, solubility increases. The graph that represents the relationship for gases and solubility and temperature, that's the opposite, pretty much, than the solids. And the only one that'll do that, solubility is going to decrease as temperature increases, and that's going to be this one right here. Okay, that's your review. Please study a bit, and we'll see you tomorrow.